It's a mission called Europa Clipper. Now, this is a NASA mission, and it's going to Jupiter's icy moon, Europa. And we'll talk about why, of course. But briefly, it was discovered back in 1610. Galileo found it. It's a little bit smaller than Earth's moon, so it's not that different, but it is smaller. Key thing about it is it has a frozen crust on the outside, mostly water ice. And that is over a saltwater ocean, and which makes it kind of interesting because potentially there could be life in there today, not something like 2 billion years ago, but now. It is possible, at least. If you got reasonably warm temperatures, you got a source of energy inside, there might be a radioactive core. They don't actually know that. That's something they have to find out. How do they even know that it has a saltwater ocean? Interesting question. Well, apparently they noticed that magnetic fields around Jupiter, which are very, very strong, are significantly disrupted by the presence of Europa when it goes through. And they found that out from probes before that have magnetometers. So they know that. And they finally concluded that there had to be electrically conductive fields. Basically, anytime you got electricity and magnetism, one way or another, you get forces and interactions with each other. And the other thing is that because of the strong gravity of Jupiter and other passing moons, the planet is kind of flexing. It's like tidal flexing, just like the moon pulling the oceans on the Earth, and that can keep things warm as well. And all that goes on, so they think there's a pretty good chance there could be life in there. I mean, it's possible. Now, they're not going to actually detect it directly, but they're just going to look for it. Now, the biggest thing about Europa, though, from a hazard standpoint, is extremely high radiation. Europa's orbit is relatively small, relatively close in to Jupiter, and as a result, it's really, really high. Jupiter's magnetic field alone is like 20,000 times that of Earth's, and so that, and there's charged particles coming out of one of the other moons, Io, and all that stuff just generates all kinds of radiation. But in any case, people say this is the most likely place to look for life outside of Earth. This is just a cutaway version just to show you that you got an icy crust. That outside, that's what that looks like. One thing they want to try to figure out is what does that brown stuff really represent? They think it probably came from cracks in the ice where every now and then water from underneath gets through with whatever other stuff is in it. And that might be what accounts for the brown. They don't really know. And then there's the ocean. They don't know how deep that is. And that's part of what they want to find out. How deep is that ocean? And it's assumed, just based on the overall density, which they do know, that there's rock and maybe a metallic core. But again, they don't really know that. They're hoping with a lot of instrumentation, with magnetometers and so on, they should be able to figure out a lot more about it. Now, as I said, the big question here is, are conditions suitable for life? And again, they're not directly detecting it, but what they're going to try to identify, their specific goals are figure out how thick that ice crust really is, figure out the ocean depth, and there may be subsurface lakes. And even in those subsurface lakes, there could be life as well. There is geological activity. You can tell that from that previous picture. There's all those strange-looking cracks and things. You don't get that from meteors. This is something that's going on inside the planet. The one thing they're hoping for, they've seen this on other moons, is you might occasionally get a crack in the ice. For instance, it might be opened up because you get hit by a meteor, or maybe just due to the various forces that you get a crack. If they get really lucky and then some part of the ocean underneath shoots up, they'll be able to sample it because they're going to be taking samples of actual material. They're not just looking at it. They're actually going to be able to analyze some of the stuff. They actually had a probe that went by a different moon. I think it was Enceladus that went by. They got lucky, and it actually managed to fly through one of those plumes. So they know this kind of thing can happen, and they're hoping it happens here. And
have they seen plumes?
I'm not sure. I think maybe, but maybe are they big enough to be of any value? I'm not really sure on that one. But they are hoping to determine the compositions of the ocean and the surface. So how are they doing all this? Well, they have a variety of scientific instruments. Obviously, that's what the Europa probe itself looks like. They're taking images. There's optical and infrared, thermal, getting a feeling of how temperatures are distributed. Spectrometers, they have the optical type, ultraviolet and infrared, which is commonly used for figuring out composition, and also mass spectrometers. This is when they sample dust and particles in the general area. They can actually analyze those as well. They analyze magnetic fields. They have radar, including subsurface radars, just like the way people have seen down inside of Egyptian tombs and that sort of thing. You can see through the ground with the proper frequency and power in the radar, and various ways of sensing gravity. So they are looking at the surface and what's underneath the surface. And to really see what's underneath the surface, that's why you need to be there. You just can't tell that well from here. And as I said, they're not only looking at the surface, they're actually going to be collecting gas and dust. They'll be close enough. The spacecraft itself, It is the largest one that NASA has ever built for planetary exploration. With the solar panels open, it's about 100 feet wide. Those are the solar panels there. You can get a sense of the scale. It's not skyscraper size, but they're big. There's people in that picture. There are 5 panels. You can see the 3 of them there. They're kind of folded. And there's 2 of those on the spacecraft itself. So the thing, it weighs about 6.5 tons. And there's a lot of propellant. The actual weight without the propellant is called the dry weight. That's at 3.6 tons. And the whole thing cost over $5 billion. So this is actually a big deal for NASA. It's one of their very large-scale projects. Most projects don't cost that much, or at least they try not to make them cost that much. Now, launcher, that was an interesting story, because originally Congress pretty much said you have to use SLS, the Space Launch System. But in 2021, NASA concluded that that just wasn't going to work. And then they switched to the Falcon Heavy, SpaceX, for a whole lot of reasons. And they actually had to get an act of Congress to be able to do that. Congress really sets constraints on design on a lot of our rockets, and that was one of them. A big issue is simply cost. SpaceX is delivering this for $178 million. At the time, SLS was estimated to cost $2.5 billion per launch. And actually now it's more like $4 billion. You know, it's added up. They've done more audits, and they've actually gotten a better feel for how expensive it really is. So it turned out that was a good thing. But there were other issues besides just the cost. Availability is a big one. SLS was not really set up for having a lot of launches. The few that they were going to make and the manufacturing capability they had only supported the Artemis program going to the moon, pretty much. And so maybe they were expecting to build one every couple of years, that kind of a thing, and there just weren't any available. So there's risk on the schedule because SLS hadn't actually flown yet at that time. Second thing is, from testing, they knew that they were going to get a lot of shaking from the solid rocket boosters. The SLS is the rocket on the left there, and you can see where the big flames are coming out. Those are the solid rocket boosters. They apparently generate a lot of vibration, and they figured out from testing that the probe itself wouldn't stand up to that. So that was actually a big problem. So that would have meant they had to redesign the things and then remanufacture, and that would have added a lot of schedule risk and, of course, a lot of extra costs. They figured it was an extra $1 billion to do that. So they said, okay, they can just do the whole thing on Falcon Heavy for $178 million. Now, as with all decisions, there's always some downsides. The downside here was SLS was a more powerful rocket, or it is a more powerful rocket than the Falcon Heavy. So the SLS, they could have just directly flown there and then done it in 3 years, which is pretty fast by interplanetary standards. The Falcon Heavy is not quite powerful enough to do that. What they have to do instead is fly by planets. Like they fly by Mars, they get a little gravity assist by getting pulled by the gravity of Mars and also accelerating when they're in close. There's the Oberth effect, it's called. It allows them to get a little extra oomph out of their limited propellant.
Slingshot.
Yeah, it's a slingshot thing. You've all seen it on Star Trek when everybody stands there and they come in real close to the planet and they're all shaking and shaking and then I hope it hangs together, Scotty, that kind of thing. So yeah, you've seen that on TV. They're doing that, of course, and they're going to go by Mars and actually going to make a pass coming back past Earth again. Even. As a result, it takes longer. It takes 5.5 years to get there, which really is not that big a deal in terms of interplanetary robotic exploration. If you're sending people there, that'd be a problem, but for robotics, not a problem. As a side note, it turned out there had been recently, until yesterday actually, a grounding of all the Falcon 9 rockets by the Federal Aviation Administration. But it turns out that wouldn't have affected this particular flight because it's licensed by NASA. The regulatory environment for rocketry is still really kind of up in the air. And who decides, it's not even clear who decides. Basically, if NASA really says, I want to be responsible for this, they get to be responsible. If the FAA says they want it, then they fight. But usually if NASA speaks up for it, they do it. Usually the deep space kind of stuff like this, NASA would take responsibility for those. Now, when they get there, I was talking about the high radiation environment. This is a picture showing Jupiter in the center. The red zone shows the really high radiation area, and then the yellowish-orange is less intense. Now, Europa's orbit there, it's not the innermost moon, but it's inside that red zone. That radiation environment is terrible for people. People couldn't survive more than a day there. But it's also terrible for instrumentation. And so they figured, okay, what they had to do, well, first of all, they're putting all the electronics inside of a big metal box to help shield themselves from that. And they had special radiation-hardened electronics as well. But even with that, they're worried about it. So what they're doing is they're having an orbit that goes around Jupiter, and they're just going to keep making passes around and around, each time intersecting the orbit of Europa and coming close, actually coming closer a little each time. And by doing that, that says they spend most of their time not in the high radiation area, and so they can recover a little bit. There was a big scare about this, though. Up through May, they thought things were fine. Somebody ran some additional tests on the radiation, and they found that the transistors that were used, key electronic components, they weren't surviving. Even though they were radiation hardened and inside that vault, nonetheless, they were having all kinds of real problems. So they studied it and finally concluded that the transistors would actually heal themselves when they got outside the radiation, which sounds pretty bizarre. It's like it's damage to the crystalline structure of the semiconductors that are making up these components, but they kind of recover on their own, and especially if they're heated up some, even just to room temperature, because normally they're going to be colder out there in outer space. Now, they refer to this as a form of annealing, which is kind of interesting. A lot of people have heard of annealing associated with metals. You're going to make metal a little bit harder. You heat it up. The thing is, that metal, you'd heat it up really, really hot above a point of where there's any kind of crystallization of any sort and gradually cool it down. That's how that works. It turns out in semiconductor manufacturing, like the transistors, they have the same kind of thing. And the thing is, though, for that manufacturing, they have to take it up to 1,300 degrees Fahrenheit. So they're also referring to this as annealing, but it's obviously going on at a much, much slower rate. And I didn't really find a good explanation of why that is. But anyway, that's the wording they're using. But it's the same kind of effect. What happens is you heat stuff up above the point of crystallization normally, and it cools back down, and you get more perfect crystals as it cools back down. And apparently, just heating the room temperature, it does that much more slowly, but it's enough to help. That's what they're saying. Anyway, so NASA recertified everything and said they're going to go for it. And they have plans, though, for heating the thing up. They weren't necessarily going to do that before, so they're going to heat it up to room temperature every time they're outside the radiation zone to speed up that recovery. So they're kind of crossing their fingers on this one because they don't really know. But otherwise, it would have taken probably a couple more years, and who knows how long it would have taken to redesign everything. And this way, they avoided all that. So the mission timeline. It was supposed to have launched October 10th.
The launch was delayed by Hurricane Milton. This presentation was originally made October 12th, but the timeline here is updated to reflect the successful launch on October 14th.
Okay, so anyway, once it's launched, as I said, it has to fly by Mars and then Earth again and get some speed boost out of that. It finally will arrive at Jupiter in Jupiter's orbit around April of 2030. And then it'll actually be flying by some of the other moons as well. Finally, it gets to Europa around 2031, and then they're going to make about 49 passes, like what we're showing here. They're going to vary it, and they're going to come in closer and closer as time goes on. They'll get in as close as 16 miles.
To wrap up, here's a movie about Europa Clipper, put together by NASA and available at the link shown here.
Everywhere on Earth that there's water, there's life. We have several ocean worlds in our solar system. And by exploring Europa, we're getting a taste of what these ocean worlds are like.
Europa is one of the moons of Jupiter. It's about the same size as our own moon, a little bit smaller, but it's so much different. It's an ice world.
Europa probably has beneath its icy surface a global ocean of water.
We think there are thermal vents in this vast subsurface ocean. There may be primitive organisms there, similar to the original primitive organisms on Earth from which we all evolved.
When we first discovered the hydrothermal vents on our seafloors on the Earth, we also discovered life. There was no sunlight that was penetrating down that deep, but yet there was life living there.
On Europa, we're not looking for life itself, we're just looking for an environment in which life could thrive.
I just love Europa's surface. I think it's one of the most complex surfaces in our solar system. Typically, when you look at another planetary surface, it's covered with craters, just like our moon.
There are very few, shockingly few impact craters. So that means something is going on to erase the craters, just like happens here on Earth, and on Earth we call that geology. One of the key questions right now that we have about Europa is whether or not there's plume activity.
Plumes are one way that you can definitely get ocean material to the surface. We really need a spacecraft in the system that's watching Europa to see when those plumes are happening, if they're happening.
The Europa Clipper mission will be the first in-depth exploration of an ocean world.
Europa Clipper is orbiting Jupiter, and it's performing 49 flybys of Europa. And the main reason it's doing that is to stay mostly outside of Jupiter's really intense radiation belts.
Each time we make a flyby, we turn on all of the instruments at once.
Most of us know about cameras because that's what our eyes see, but there is a whole slew of other instruments on board Europa Clipper that expands our vision.
We have 4 different instruments that we're really using to take images of Europa's surface. We have the visible wavelength, the near-infrared, the far-infrared, and the UV, the ultraviolet.
We're hoping to see evidence of change, new cracks, new surface colors that indicate different materials maybe have moved around or come up from the subsurface.
We have an instrument that can sniff the very thin atmosphere, the gases, and determine the composition with extreme precision. We're looking for signs of organics at Europa. Are there materials that contain carbon and hydrogen and oxygen and nitrogen? And we have another instrument that can tell us the composition of dust particles. We're pretty sure there are salts on Europa's surface, and those salts may have come out of the ocean. We want to understand what are those salts.
We have a magnetometer and a plasma instrument that are going to be studying that magnetosphere environment that Europa is sitting in and Jupiter's magnetosphere environment.
The magnetic field of Europa, in turn, can tell us about the properties of the ocean. How thick is it, and how salty is it?
And then we have this novel ice-penetrating radar that will try to get below the ice shell.
Last but not least, we have a gravity experiment using the communication system of the spacecraft, and from that we can get essentially a map of the gravity field.
We can get the shape, understand what's underneath, maybe even get some information on the depth of the ocean. It's really a sophisticated payload.
So there really has not been a mission like Europa Clipper. The pictures that we are going to get back are going to be just fantastic.
The legacy of Europa Clipper will be just a treasure trove of knowledge about this world.
Just to find an environment that is similar to the one from which life arose on Earth would really be groundbreaking. It would be awesome.
I have no idea what we are going to detect beneath Europa's icy surface, but all I know is it's going to be wonderful.
We do this work of exploration for the next generation. We don't know if Earth is the only place that life got started, or if it's really common. And a really important way to get at that is to understand, is there life elsewhere in our solar system?
Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and a link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.